So my PhD is a story about the birds and the bees. It's about sex, but it's about plant sex. And in case it's been a little while since you did your high school biology, plant sex is pollination. It's a transfer of pollen from the male part of a flower to the female part of a flower. But unlike humans and animals, plants can't really go looking around in order to find that desired mate, so they need a lot of help for the connection to happen. Sometimes it's as simple as wind or water carrying the pollen. Often it's done by insects such as bees, but what I'm most interested in is when it's done by vertebrates. I'm talking about small birds, rats, bats, even the occasional lizard, all of which feed on nectar or pollen in the flower and then carry a tiny bit of that pollen across to the next plant that they visit. My PhD is focusing on this guy, the red and green kangaroo paw, or Onyxanthus manglesii. It's visited both by native nectar-feeding birds that we call honeyeaters, as you can see in the bottom corner, and by the introduced European honeybee. And this gives me a great chance to look at bird and insect pollination on the same plant. To do that, I use a pretty simple experiment. I put nets around different plants in the wild. Some I net so that the only thing occurring is self-pollination when the flower pollinates itself. Others I use chicken wire, which allow bees access to those flowers but keep the birds out. And finally, I leave some open, which allow both bird and insect activity. We have to use this categorical approach because there's currently no good way of allowing birds access but keeping the insects out. What I found is that birds are critical for the pollination of kangaroo paws. Not only do flowers that have been visited by birds produce up to 50% more fruits, those fruits contain up to 90% more seeds, which makes a huge difference for the survival of the species over the long term. Insects, in fact, do just as badly as self-pollinated plants, only producing around 5 seeds per fruit, while bird pollination can produce over 100. The reason why I think insects are so bad compared to birds is because when it comes to pollination, size often matters. Kangaroo paw flowers have evolved to perfectly fit bird pollinators. They drink nectar at the base of the flower and they brush up against the reproductive parts up here. Bees, on the other hand, when they visit the flowers, completely bypass that reproductive area altogether and just really are focusing on gathering pollen for themselves or pleasing themselves with nectar. My next question is why? Why would kangaroo paws, or any other plant for that matter, evolve to promote bird pollination over bees? And our theory is simple. It's because birds can travel further than insects ever could, so it means you can spread your pollen over vaster distances. To test this, I'm collecting seeds from each one of these categories of plants, and I'm using genetic techniques to assign the father to those seeds. That way I can tell you exactly how far that pollen has been carried by different pollinators. And these sorts of studies are incredibly important here in the Southwest, as we actually have the highest percentage of bird-pollinated plants in the world. And we hope that by getting a greater understanding of what's going on in these systems, we can help make smart management, restoration and conservation decisions to keep them here for the long term. Thank you.